Good morning, everybody. Welcome to my session on Type B RCCBs. Okay, this morning I will be, this is the agenda. It's going to be a very brief refresh on what an RCD is, and when I say brief, it will be very brief. Then we'll move on to the various types of RCDs and their applications to give everybody a better understanding of the various types that are available in the market. From here, we'll move on to specifically Type B, earth leakage protection. What is it and when do we need it? I'll then highlight some typical Type B RCCB applications and then run over the Schneider Acti9 Type B offer. We'll follow this up with some frequently asked questions and a Q&A session. So if I could ask anybody that has any questions during the presentation, if they'd please put them into the chat window and we'll address those at the end of the presentation. So just quickly before we start, who am I? My name is Martin Scottorn. I'm a product slash offer manager for the final distribution category for Schneider Electric in New Zealand. My background, I'm a qualified electrical engineer and have 26 years experience in the electrical industry working for PDL and Schneider Electric. I have extensive product knowledge and experience with product safety, compliance and standards. What is a RCD, residual current device? So residual current devices protect, most importantly, people against electrocution, or the risk of electrocution, I should say. They're also capable of protecting property from the risk of fire due to earth leakage current. 30 milliamp sensitivity is what is needed to protect people against the risk of fibrillation, and 300 milliamps is typical of a device that's being used for indirect contact protection and protection from the risk of fire due to small earth leakage currents. When earth leakage current is in excess of the device's sensitivity, in this case a 30 milliamp rated RCD, which is the maximum permissible limit before putting a person at risk of heart fibrillation occurs, the RCD will detect an imbalance of current flowing in the live conductors and opens the circuit, breaking all the live conductors within a specified time. A quick reminder of what RCD is and what it's used for. So RCD is a key device within the electrical installation. It's continually checking the level and presence of earth leakage current, and it's able to react in a few milliseconds in order to disconnect the supply. It protects the electrical installation against fire, and most importantly, it protects people against the risk of electrocution. They save lives. Said it was going to be brief, that was it. Moving on, the different types of residual current devices and their typical applications. So depending on the load, the earth leakage current that will be generated when there's an issue are different. So different types of RCDs are defined in the standards to detect and trip on those different types of earth leakage waveforms, and also to avoid nuisance tripping. AC type is used for linear loads, class 2 small appliances. They detect pure sinusoidal current at 50 Hertz. And typical loads include the likes of incandescent lighting, electrical heating, purely resistive loads. Type A, these are for class 1 electronic loads. These are commonly known as detecting or capable of detecting sinusoidal and pulsating DC. Type A RCDs, this is what is mandated for use in New Zealand. Okay, so type AC devices are not allowed for use in locations where RCD protection is mandated for use in New Zealand. Typical loads include electronic devices, computers, dishwashers, those types of things. We then move on to type F. F-type RCDs are not commonly known about in New Zealand, but they're specifically been designed for the likes of single-phase speed drive loads, where an earth leakage current can be a mix of frequencies. F-types are capable of detecting these combinations of mixed frequencies. Okay, so a classic example would be of classical example of a load would be a single phase air conditioning unit or heat pump, a swimming pool pump with variable speed drives, and some advanced washing machines which also have variable speed drives. Schneider has what we call a Type A SI. Now Schneider's range of Type A SI RCCBs are able by design to detect these same combinations of earth leakage currents as a Type F. There's also some advanced features built into our Type A SIs, and we like to recommend them for locations where continuity of service is important. So anywhere where a customer has experienced nuisance tripping, then we would immediately advise them to adopt the use of a Type A SI. So nuisance tripping, that's essentially when the RCD trips when there is no danger to a person or animal of electric shock. And these nuisance trippings can be caused by things like high frequency leakage harmonics or transient disturbances, which can be the switching of large loads or potentially lightning strikes and things like those. The Type A SIs are capable of filtering electromagnetic disturbances and those high frequencies out. They have an increased immunity against transit current, and like I mentioned, they're recommended for all applications where there's been a request of high continuity of service. So again, those types of locations could include hospitals or data centres. We then have Type B, which is the main topic of discussion today, but I'll get into the where and why we use them in just a moment. Just to quickly recap on those different types before I deep dive into Type B. AC detection, pure sinusoidal, for household devices, small electro-domestic loads, incandescent lighting, etc. Type A, detection of sinusoidal and pulsating DC. Type A obviously provides the same protection as Type AC, but with the additional pulsating DC detection. These are what Type A devices are mandated for use in New Zealand. Type F, detection of mixed frequency earth leakage faults. Typical loads include air conditioning or pumps, single phase pumps with variable speed drives. We then have our Type A SIs or F SIs, B and BSI. Just to remind you, SI, these are specific to Schneider Electric and are for locations where continuity of service is important. So the likes of an ASI is a Type A, but with reinforced immunity against nuisance tripping. The important thing is the choice of the RCD type should also always be done in according to our national installation rules and regulations, but taking into account the characteristics of the load and also manufacturer's instructions of those loads. Earth leakage protection Type B. What is it and when do we need it? So first up, B-type protection is the best RCD protection in the market. Okay, it's used in installations that could produce frequencies between 50 Hz and 16 kHz, as well as smooth DC. We recommend the use of Type B SI RCCBs in locations where there is UPS equipment being used, medical equipment, HVAC, photovoltaic, electric vehicle charging, cranes, lifts, or industrial speed drives. So very, very crudely, a Type B RCD essentially is a Type A with additional protection against DC leakage. So it's two RCDs in one, essentially. It has a Type A voltage independent RCD in it, as well as a B-type voltage dependent RCD in it. They operate in parallel. They have two different detection toroids built into them. Okay, one of them is, like I just mentioned, is essentially the Type A RCD, and then we have a second toroid which is used for detecting smooth DC. Important notes: B-type RCCBs need to be placed on the AC side of the installation. Okay, B-type cannot protect pure DC installations. Okay, they're not intended to be connected to a DC network. Okay, they're always on the AC side of the installation. Why do we need them? So in the case of a three-phase drive, which has a rectifier and an inverter, to be running a motor, or asynchronous motor at variable speed. We also need them for converters, so where there's any conversion of AC to DC or vice versa taking place. Three-phase photovoltaic systems also. So any of these types of loads or installations are capable of producing earth faults that can occur in both the direct current section as well as the AC side. They capable of producing earth leakage currents for DC components and of mixed frequencies. So it's these types of earth leakage that will not be correctly detected by your traditional type A RCD. Okay, and this is why we need the B type. So what does all that mean? Long story short, even loads on a 50 Hz AC electrical installation can have residual currents that contain smooth DC components or frequencies higher than 50 Hz or a combination. And it's these applications that require the special type of RCD. Type B RCDs are used for their ability to cope with smooth DC leakage current that type A's can't. Type A RCDs become what we call blind. Does blind mean that when referring to an RCD? It means they can trip at leakage currents above those stated on them, or potentially not trip at all. Okay, so if you can imagine a 30 milliamp device that is blinded, if there's a earth leakage fault that's in excess of the trip threshold of that device, but in the presence of smooth DC, it could shift the tripping characteristic of a type A RCD to a point that is unsafe. That could be 45 to 60 milliamps, let's say, for example. Typical applications. First up, industry. Okay, in industry there is a lot of use of three-phase speed drives, wastewater installations, cranes, packaging plants with conveyor belts. All of these locations use variable speed drives. We need to ensure we have the correct RCD protection in place so as to ensure both production continuity and protection to people. Next we have, more specifically, the variable speed drives in, specifically. Okay, here's a quote. This product speed drive can cause DC current in the protective earthing conductor. Where a residual current operated protective RCD device is used for protection in case of direct or indirect contact, only an RCD of type B is allowed for the supply side of this product. Okay, variable speed drives, it's well known that they are capable of producing earth leakage currents of various frequencies where a type A RCD is not suitable for use. It's also now mentioned in the IEC standards 61800-5-1, which is specifically for the safety requirements for electrical and thermal energy when VSDs are in play. Other examples of locations where we should be being careful we've got the correct type of RCD. Buildings, okay, so we want to improve the level of service in buildings and avoid any disruption or electrical hazard that might put people at risk. Elevators, things like this, air conditioners, escalators, all of these types of equipment, again, where variable VSDs are in use, we need appropriate protection and class of RCD. Again, has been adopted in the specific standards for those locations, so safety requirements for power electronic converter systems and equipment. We then move on to electric vehicle charging stations. So electric vehicles, as we all know, are becoming increasingly popular, and charging stations are needed for the charging of these vehicles. Electric vehicle manufacturers claim that the potential for DC earth leakage is possible. okay, especially on three-phase chargers. So this is where we need to, again, ensure we have the appropriate Type B RCD protection in place. Yet again, there is specific standards requirements for the correct use of Type B RCD protection for the installation and locations of supplies for electric vehicles. Photovoltaic installations, these two have a requirement for Type B RCD protection. Photovoltaic systems use inverters, converters, which require the B-type protection to be compliant with various international standards. Yet again, IEC 60364, requirements for special installations or locations, solar photovoltaic power supply systems. They are called up, B-type RCD protection is now called up in that standard. Specifies requirements to reduce risk of fire, electric shock, thermal, energy and mechanical hazards during use and operation of this type of photovoltaic installs. So just to recap, RCD segment by application. Residential, we're looking at Type A. Tertiary, Type A or ASI. Buildings where essential supply is needed, should be recommending the use of SI or ASI or BSI. Industry, where there is plenty of variable speed drives, etc. in use, depending on the specific load characteristics, either ASI or BSI. Photovoltaic installations, again, ASI or BSI for three-phase. And we have the electric vehicle requirements for Mode 2 and Mode 3 chargers should be using a Type B RCD protection. So next, Schneider has a new Acti9 Type B SI and BEV range. With the increased demand for Type B RCDs, we've recently launched this new offer. We have a specific offer for electric vehicle charging. In this offer there are 5 references, 2-pole devices, 16, 25 and 40 amp. We also have 4-pole devices, both 40 and 63 amp. We also have what we refer to as our international offer. These are our Type B SI type devices. There's 20 references in total. I won't go through them all, but they range from both 2-pole to 4-pole devices, 25 to 80 amps, with sensitivities ranging from 30 milliamps to 500 milliamps. Keeping in line with the rest of our Acti9 offer, they're fully integratable and compatible with our existing Acti9. So they're connected, obviously compatible with our power tag and energy monitoring solutions, compatible with our auxiliaries and ARAs, etc. And they've been tested specifically with use of our own variable speed drives, ensuring that our Type SI technology is working as it should be to avoid nuisance tripping. They have all the common features you would expect of Acti9 products, things like a Visi trip window, the Visi safe. These new Type B RCDs have voltage presence, LEDs. We have our insulated terminals and shielded terminals, and a large clear labelling on the front of the products. The new 2020 A4 catalogue, okay, all these devices are now included in that new catalogue. If you haven't got a copy of the new A4 catalogue, it is now available for download on the Schneider New Zealand website for you to view. Substitution-wise, if any of you are doing a substitution of a old Type B device, there's no issues there. Easy substitution from the old range. They're both 4 modules in width. The performance of any new BSI type is significantly improved upon the old offer. If you require devices in excess of 80 amps, we have retained our old 125 amp RCCB B-type that is still available. Frequently asked questions. We've started collating as questions come in from various users and installers, creating a database to enable us to quickly respond to types of frequently asked questions. So I won't go through all these, but let's just be assured that we have started gathering this information, and so we can provide answers quickly to anyone that requires it. Support tools. We have various range of educational support tools available at no cost. Okay, these include e-learning modules. We have a demo case which can demonstrate the advanced RCD protection and the key differences between our Type A, ASI, and B devices. Okay, we have application sheets which are also available for anyone wishing to pass on a quick cheat sheet or information to a potential client. Okay, and they're specific to the various types of applications. So as you can see, the SP drives, photovoltaic, cranes, medical facilities, etc. We also have a new complete earth leakage protection guide that is available. This is a very good document. It's quite a bit of reading, but anyone that wants to deep dive into RCD protection, what it's all about, how it's come about, and the reasons and standards driving the evolution of RCD protection, earth leakage protection, then there's some good information contained in that. There's also a B-type, what we call a white paper, that has been written by our in-house gurus, for lack of a better term. Again, they've done a very, very deep dive into the use of Type B RCD protection, why you need it, and where best it is used. Thank you very much for your attention. I hope I managed to pass on a little bit of information that you didn't already know, and hope you all have a good afternoon.